So just very broadly, we've looked at sketching. I think we went straight into 3D, didn't we? So we had a 3D design kind of session around Fusion 360. I really kind of wanted to concentrate on 2D because it's quite easy to take that to a laser cutter, or if you can take it to a laser cutter, which we've all done, I hope, the same file can go to a water jet cutter, so you can get metal cut. It could go to a vinyl cutter, as I showed and demonstrated in the session. What else have we got? We could send it to the CNC router, of course, which is a great big machine that can cut out bits for furniture. Yeah, I mean, so there's lots of applications just for 2D things as well. Then we went on and we looked at 3D printing. We looked at the software and all the free software that we can actually download. And I've got to say, I think what Fusion, which is by Autodesk, are doing is they're kind of bringing in all sorts of different elements into one platform, which hasn't really been done before. There are some amazing things with Rhino. We started off with Rhino 6, or it was Rhino 4 when we started. It's up to Rhino 7 now, I think it is. But every year you have to, or every couple of years, you have to upgrade to the next version, let's say, which is very, very expensive. And the thing about Fusion, of course, is it's free. But they're very, very clever in there's different methods that you can work within the same platform. So Rhino is very nuts and bolts as well. It's very kind of engineering by feel. So you draw something, you extrude something, and it is quite geometrical in nature. And then you get something called SolidWorks, and SolidWorks works very like Mesh Mixer. You remember we had this kind of object that we can push and pull and kind of manipulate, almost like virtual clay. And that's what SolidWorks is. And do you remember, I don't know if anybody remembers the later versions of Doctor Who when they came out, the Cybermen came out. You could see straight away that's done in SolidWorks. You can tell by the forms that were created by the designers. And then you've also got AutoCAD, which again is very nuts and bolts. And I think using Mesh Mixer last week has given us this kind of range, this wide range of the different types of CAD operating systems that are out there. And I think what's going to happen is Mesh Mixer will disappear soon, and it will be all within Fusion 360. As Fusion 360 is developing, it's just grabbing all sorts of things and throwing it in there, which it can do, of course, because it's online. It's a supercomputer that we're using. Thankfully, we're not using the processing power of our laptop. So that's pretty much everything we've covered, I suppose. I think what Owen is going to do today is we're going to look at CNC milling and taking our model out. And as 3D printing, of course, is a additive process, so it will kind of obviously separate our model into lots and lots of different layers, and then work out how to print each layer one on top of another. With this, what we're going to do is we're going to talk about a block of material, and the software will now, again, it'll put it into layers as a tool bit, as a tool will come around and make contact and start cutting away. And we have to decide how fast it's going, just like we do with a laser cutter. We also have to decide how many drops down it's going to go to be able to cut away that material. And of course, if we're using blue foam, polystyrene, we can go down really fast and really kind of cut away a lot very, very quickly. If we have a hard wood or even up to a metal, we're going to have to be traveling very slowly, and we're just going to take small amounts. And it is very similar to our settings for the laser cutter. We would travel at a different speed, and we would cut at a different, let's say, sensitivity. Because if we cut too deep and we go too fast, we'll just snap that the tool. So that's pretty much a kind of a quick overview of what we're doing now.
Okay, so I'm just going to continue. Okay, so welcome to session 6 of this design and make part 1, level 1. I think that's what it is. And today we're going to look at CNC machining. What I'm doing while I'm struggling with this tripod. And I think what it emphasizes the fact is that when we're working with technology, it doesn't always go right at all. Often we do get thrown, as they might say, a curveball, or if you're a cricketer, a googly. So today's course, today's session is going to be in two parts. Firstly, we're going to look at certain aspects of Fusion. We're going to look at the inspect tool, but then we're also going to guide you through creating some lofts. And the reason being is because these are going to be useful for setting up files for machining. Now, the reason why we're going to use lofts, because it's a little bit more complicated, because you need to create numerous construction planes to do it. There's reasons why we're using lofts. And also, this is going to bode us well when you might want to create a file that you can send to us for myself to machine it. That's the crux of it, really. I'm just going to chuck this tripod over here. I'm going to need that later. But firstly, when we're designing for machining, we have to take certain things into consideration. And generally, and this will affect directly how we design. So we're designing for machining as opposed to 3D printing. We're designing for material to be removed as opposed to added. And what that means is that when we are designing for stuff to be machined, we can use just surfaces if you wanted to. What this means is that you can cut corners when it comes to machining stuff. You could be lazy. And the reason why I say that is because if you've got a virtual solid, not only could that be 3D printed, that could also be machined as well. And often, if you've got something that's got multiple sides, that's something that you would need to do. Okay, I'm not going to worry too much about that. Now, I've got a little demonstration as to the reason why you have subtractive and additive processes. You've got to see it, well, you can see it how you want. You have to see it in terms, though, of when you are removing material, you're removing it to a constrained border. And so thereby it doesn't have to be solid, you know, you're removing the material. Whereas if you're 3D printing, for example, you're adding material. And so you're essentially filling something up from the inside. Okay, so I'm just going to share a little animation with you. Let's go, or let me just put it on a window. There we go, showing the entire screen. Okay, so you should see a blank screen in a minute. Where's my mouse? And so this is additive. And as you can see by this animation, it is adding layer by layer by layer, as if it's filling it up from the inside out. Okay. I mean, obviously there are the mechanical constraints, whereas subtractive, you are removing material to show the object that's inside. So you are working from the outside in. Okay. And once you've kind of got that in mind, once you've got that kind of thing in mind, it makes it a little bit easier in terms of, might make it a little bit easier in terms of how you design for this. So before we look at Fusion and this kind of thing, I'm going to show you some examples of what we've got and what we've been working on over the years. We don't really have that much because our students and other participants tend to take their stuff home, which is jolly inconsiderate of them. So to start with, we got something like this. Now, this was a 3D scan. It was a 3D scan taken of a mask, a wall mask. And what I did was I then machined it out of this terrible stuff, which is polystyrene. We use polystyrene because it's really quick to use. I'd say it's cheap, relatively so, but environmentally it's exceptionally expensive. As a side note, we are looking at other materials that we can use instead of this, maybe like compressed miscanthus, elephant grass, or even mycelium, which is basically some kind of fungus. Anyway, so this is a test piece, and the reason why we made it is to see if the machine is capable of producing something so big, or more to the point, so deep. And it's an important thing to understand, because when you're designing for particular equipment, you need to know its working parameters, i.e. its maximum length, its maximum width, and of course its maximum depth. Okay. Now this was good, it worked. So then we machined the finished item in something called lime, which is a wood. I think it's also known as boxer wood in certain parts of the world. And the idea that you would use that is you would say get wet leather. So this was designed for costume. So you'd get things like wet leather, and you would stretch it over that form, this form here, and you would staple it around the back. And once that leather dried, you'd take it off and it'd form a facsimile of your face. So you could make masks that would fit a very prescriptive, defined features of someone. Okay. So in that case, we can make things like formers, and often we do make a lot of molds. In fact, I'm running a mold making course tomorrow, an introduction. I'm just going to grab a really good example of something that was made from molds. Just bear with me. Now, it was through CNC machining, actually the design that was fed into it, that we could make things like this. So we make things like this. And this is a vase. It's completely asymmetrical. And so this was created using a 4-piece, 1, 2, 3, 4 around the sides mold. We would, yes, we could have created that as a 3D printed object, although it is quite large. However, the process that we used, or was used in this case, ceramic slip casting, it calls for something that's made of like plaster of Paris, or something that can wick away water, because that's how that process works. Now, we just couldn't print anything of that kind of nature. Okay, so I'm just going to put these somewhere safe. And there's the finished object, glazed and embellished. This was an ex-student of ours who produced these. We're super grateful that she left these 2 pieces with us. Milling can also make artistic sculptural pieces. So I've got a piece here. This is made by a European artist who's based in Berlin, an American guy called Mark von Rosenstiel. And he used milling as a particular process whereby, generally speaking, we would always hold down a workpiece. We wouldn't let it move. But he had this kind of loosely fixed with inside a milling machine, and he gently milled it. And the reason being is he wanted to create something that could, by machine, that could not be recreated. Of course, there's massive holes in his argument, because I could just 3D scan that and make lots of them. But the idea is interesting. And also, we can make things like artistic installations. This was designed by an architectural doctor called Adriana Ionescu, who's based in Belfast. And she wanted to test the idea of these kind of structures to scale. I mean, to produce these like on a 1-to-1 scale would have been really pushing it. Not only would it take a long time, we certainly wouldn't have been able to machine it so easily. And there's a figurine 4 scale as to what they are and how they would function. I'm not quite sure what they actually were. You'd have to contact her regarding that. But it goes to show the kind of versatility that this kind of technology has. And it's mainly based on things like scale, because milling machines generally are much larger, can produce much larger objects than 3D printers. Okay. All right, now that's all well and good. I've shown you some nice examples. Well, I'll show you this last one. It's of, I believe it's something that's within the Sistine Chapel. Ian will correct me. It's one of his MA students who he's helping to work on. I've machined this for them, and basically it's an angel. It's had its wings clipped, so it's obviously gone to hell. But its wing is here, one of them. Okay. Now, there are those milling machines that can actually reproduce this in sort of one go. They might be 5 or 6 axis machines. But generally speaking, the milling machines we have only have 3 axes. And from the get-go, I always made it quite clear that it is important to understand the axes, the x-axis, the y-axis, and the z-axis, okay? There is also another axis which this was produced on. It's called the A-axis, and it is an axis of rotation. And this A-axis is parallel to the x-axis, and it just rotates along it. But that's as far as we can go with such things. So anything complicated, more at the point, anything with undercuts are really problematic to make. So for example, this guy here, he was machined flat. He was machined flat. If we tried to machine him in this direction, where his nose is, which you might just about see, you would not be able to get that profile underneath. It would be straight down. He would have a proper beak on him. Okay? And this is a problem. And so it has to be thought of carefully when you're machining stuff. So when I showed you that little bit of footage of the demonstration vase, when it was looking at additive processes, it was upright in its proper position, how it would actually exist in real life. Whereas if we were to machine that, or a mold, not only would it not be hollow as such, we'd have to machine it on its side, because the lip of it would perform that undercut. And so thereby you would just have near enough a straight cylinder. And that's not what we wanted. Okay? So that's a bit of machining in a nutshell. I've kind of got ahead of myself. I was going to look at inspections, but we will look at that as well. So what I'm going to do now is we're going to turn to Fusion, and we're going to basically, collectively, hopefully, create a few items that could be fit for machining. And so what I want you to consider, this might well be the last session, but it doesn't mean you can't send us stuff. Things that you can create that could potentially be machined. And yes, we will more likely machine it out of polystyrene. Okay, so I'm going to share my Fusion screen. If I can find it. There we go. Okay, so I've got a blank screen. I'm ready to go. Now, generally speaking, I tend to work in the orientation that either it's going to live, existing, or I work in the orientation that it's going to be fabricated in. But it's much the same. So what we're going to do is we are going to do an exercise that involves lofting. Okay, and lofting is something that you can find in either solid. So if you go to the Create tab, I'll open that up, and it's kind of here. It's under Sweep. There's Loft. But lofting also exists under Surface. And there it is too. Okay, now the thing is with Surface, as I discussed in sessions prior to this, it produces a boundary that has no perceivable thickness. Yes, it is a form. It is a representation. Suitable for machining? Yes. 3D printing? No. But we're going to stick with solid. Now, last week I did say we were going to look at this thing here called Create Form. Potentially we could still do that, but I want to try and engage you to using more than one plane, and also to create something that utilizes not only various sketch tools such as splines, maybe, particularly splines actually, but also things such as text and how text can be used in the thing that we're hopefully going to be creating. Okay, so what I'd like to do, or what I'm going to do anyway, is I'm going to create some construction plans. I was going to go and create a sketch first, and yes, I could still do that, But first I'm going to create a construction plane. So you can find that under the solid tab here. So you've got create, modify, assemble, construction, and lots of different tools. We're going to just go for the bog standard offset plane. Okay. And when we click on this, we are presented with the three standard planes, i.e. the X and Y, oops, or the, if I just, you get a dialog box and it says plane, one selected. You can only select one. I'm going to cross that off so it resets it. We could select the X and Z, like so, in that direction. Well, of course, we can we could select the Y and Z. Okay. I'm going to select the top plane or the bottom plane, depends what you want to call it, but that's the X and Y. And as you notice, there's an arrow here, so I'm going to drag that up, and that is the offset. We're not moving that original plane that we selected. That stays, that remains, that always will remain. But we're moving that relative to it, and you can move it by any amount. In this case, I think I'm just going to move it by about 10 millimeters. So the question I'm going to pose to you right now is, how do I know how much to move it by? What would I know? What do I know, which you don't know yet, but what do I know which would influence how much I will move this offset plane? Bearing in mind that I'm going to create more than one. I might create 4, okay? And each one might have an interval of 10 millimeters. What is it that I know that you would need to know whenever you are designing pretty much anything, really? Anyone want to shout out an answer? Well, the thing I know is, I've got an example. Not really. Oh, yes, I have. I know how big my material is. So, like if you're 3D printing, you need to know how big the machine is that you're going to print stuff on. Yes, you kind of need to know how big the milling machine is that you can put of the maximum size material. But in this case, I'm only doing small objects. So I know that that material here is 75 millimeters. I'm really just guessing. I don't know at all. I presumed it was like 100, but it doesn't matter. It's going to be in that orientation. And sure enough, it's 75 millimeters. It is important to know how big your object, your piece of material is. And so I could say to you, for this exercise, your material that you're going to use is 100 by 100 by 100 millimeters. Okay. And that 100 by 100 by 100 cube will be machined in one direction, not 2. Although I will talk about that, and if you're feeling brave, maybe we could do that as well. Okay, so that's something important to know. I'm going to use 100 mil by 100 mil by 100 mil. Okay, so I've created a construction plane, and yes, I could divide that 100 millimeters up in a series of different levels. I mean, that's 10 construction planes. That means that we'll be creating 10 sketches to fill it. That's probably too many. Maybe we'll go for 4. So that will influence the spread of your construction plane. So instead of being 10 millimeters, it's going to be like 25 or thereabouts, okay? Now, if, like me, you've already created a construction plane, it's already set in position, you can modify that position. You don't have, it doesn't have to be stuck where it is. And to do that, you go to Browser, and you go to section Edit Feature, okay? And in here, instead of 10 millimeters, I'm going to type in 25. Okay. Now you can change this at any point if you wish. Okay, you can change this at any point if you wish. So the next thing I want to do is create a new construction plane. I'm just going to be interfered with by the estates. Yeah. Not, they've locked the door, although they've probably opened the door because I've already locked the door. Bless them. Okay, so I want to go to construct. Now, where you offset this plane from is actually up to you. You could start from that base plane, and if you gave that base plane a number, it would essentially be 0 because it's at 0 point. You could offset it from this other plane as well. So I could offset it from there and say, oh, I want it another 25 millimeters. And you could do that. However, if you want to use the rule that everything starts on that datum point, you would select that plane and say, I want it 50 millimeters. I hope that makes sense. All right. Okay. Now, when you're creating things like construction planes, you might notice that in your browser on the left-hand side, you've got a folder that appears. It's called construction, and if you open that up, it's just got plane 1 and plane 2. That's great, but it's not very descriptive. So it might be prudent for you to rename that, as in, I'd just call it, I don't know, plane XY, and whatever the offset is. In this case, it's 25 millimeters. Or you could even say plus 25, because you can offset downwards as well, and thereby you get a minus number. It's important, I've said it before, I'll say it again, it is important to be organized. Really so, because when you come to machine stuff, or you present someone with files that would thereby be machined, this information is quite useful for whatever software is being used. So I want you to create 4 construction planes, and so at 25 millimeter plus intervals. Okay, so I'm just going to do that again. Splash bosh. Oh, not that way. Not that way either. So 75. Lovely. And then finally, that one there. Set at 100. 100. Okay. So in effect, you've got actually 5 planes. You've got the 4 that you've offset, and then you've got your very base plane, which is at 0. So I'm just going to rename those. 5. And you don't have to do this in that particular order. You could have just created an off. You could have just started from your base plane and created a sketch. Okay. Can anyone remember or recall or think of a way whereby you would create a sketch and then transpose it, which is a good enough word, transpose it onto another plane, and then on that plane you could potentially modify it? You might want to hazard a guess of what tool would we use, and it's a sketch tool.
And I put a hint in chat.
That's not a hint. That's
Well, it's the answer, actually.
It is project. Yes, you would use.
Ruined it for everyone.
I haven't ruined it. You haven't ruined it. You've just oiled the wheels. That's fine. Okay, so I've got 4 construction planes, and in the browser you can turn them on and off, so you can hide them. When you create a sketch on these things, they will probably tend to automatically disappear anyway. So just bear that in mind. So I suppose I'm going to start with maybe the very bottom plane here. Okay, and that's the origin. So I can hide that. That's not a construction plane, that one there. There it is. It's the XY. There it is indeed. So I could hide that if I wanted. Or I can highlight it. But what I'm going to do is I'm going to create a sketch. Now, the thing is, when you've got construction planes like this, they are all parallel. So if I say went to that top view, I mean, you can see them, but sometimes it's actually, they are difficult to select. So when you want to create a sketch, you can do it in obviously a number of ways. One is you go to the create sketch icon, which is or should be next to the design button. And if it isn't, you go to the create tab under solid, and it's under new component. All right, so we could go like that, but still it's like, oh, which one do I correct? Which one do I select? It's a little bit fiddly. If I go up to the view cube to the right, and click on that house button, it puts them into a perspective viewpoint. And so I can select the one I want to use. Alternatively, if I go to escape, get out of that. Alternatively, if I go to the browser, I can find it there. And as I traverse over these different planes, they are highlighted in like a grey. They get greyed out like so. So I can find the one I want, which is just XY. If I right click on that, I can go to create sketch from there. So you don't have to use that create sketch button that is up top. It's quite handy. And voila, so I'm now in that sketch plane. And I know that whatever sketch I'm going to create will be on that level. In this case, 0, right at the beginning. Now it's handy, it'd be very handy just to turn off those other sketch planes. And this is where things like the browser are really important, because a lot of stuff that gets populated in there gets in the way of what you want to do. All right, so anyone want to tell me what kind of shape I want to create? Anyone? Well, whatever I'm going to draw, first I'm going to start with a point. I'm going to stick that right on that datum point there. I'm going to turn off these origins because they're just in the way. Okay. So I've got a point. I'm going to work out from the center outwards. I don't have to. You can do it any way you want, really, but I'm going to work from the center outwards. Well, the first thing I'm going to actually do is I'm going to draw a boundary. And that is going to denote the size of my block of material that I'm going to be machining. In this case, I'm going to go to create. I'll get out of that tool. I'll go to create. And I'm going to go to rectangle. There's a little side arrow there, and there's 3 ways of creating a rectangle. I'm going to use center. Okay. And sure enough, you won't. Well, I'll be surprised if you can see this on the screen, but there's a crosshairs, but just down to the bottom right of it is a very small rectangle with a tiny point in it and another point in the top right corner. So I've left clicked that to select it. I'm going to find that central point that I've created, and I'm going to left click again, and with that I'm just going to drag the mouse off. There we go. I'm going to create this square. I'm not going to press enter or any other mouse button. There's a box that's highlighted in a blue. In there, I'm going to type in 100. All right. Now, I could press enter, but I want to put the other dimension in. I'm going to zoom out. As you can see, that dimension is now locked. There's a little lock next to it. I can't get to it. It is what it is. I could change that number if I wanted to say 200, but that would be detrimental. So 100. And I'm just going to zoom out and see what's going on. But I need to get to the other box, and I could do that by either with the mouse, like so, or I could use the tab button on your keyboard. And the tab button is usually above the shift hold button. There we go. And the tab button is a right pointing arrow with a bar against it. So it's like a benchmark on its side. All right. And sure enough, that's selected the other box. And in there, I'm going to type in 100 as well. All right. I've created the box. Good. Create the square. Now, as I mentioned a couple of weeks ago, when I was talking about different line types, this is a constrained box. It's fully constrained. That's why it's got a black outline. We don't need to worry about that. But the thing to bear in mind is that it's solid. Should we keep it as a solid or not? I think no, maybe not. So in this case, I'm going to select it all by drawing a box around that, so it's all highlighted in blue. And in the sketch palette, which may be available to you, if you can see it on the right hand side, it might actually be folded away like that. If I open that up, I'm going to go to line type and construction. All right. Cool. Easy. Now, I could say I'm going to finish sketch, and sure enough, I will. Or shall I? No, because I've got a box, but I need to put something inside it, and that's going to be the base of our model. Now, the thing to bear in mind is that this base of the model needs to be larger than anything else that's going to be on top of it, because otherwise it's going to be really difficult to machine, because we're machining downwards. And as I say, anything that's got an overhang will just be machined flat. You wouldn't machine that overhang, it'll just be straight. All right? So in this case, I'm going to go and find me a polygon, and I'm going to use a circumscribed. It doesn't matter if you use circumscribed or inscribed or even edge. An edge polygon is where you measure the edge itself, and it will dictate how big it is. Inscribed would be inside the circle, and circumscribed where it actually fit outside the circle. So I'm going to go circumscribe. I'm going to select that in the middle. I'm going to, yeah, that's good. And then I'm just going to do that. Now, since everyone is being so forthcoming and shouting out like objects for me to create, I'm going to say it's going to be, well, I don't know, 40 millimeters, and it's going to be 7-sided. All right. And now I'm going to go finish sketch. All right, so I've got one sketch there. I've got another 5 to create. So once you've done that, I'm going to turn off that origin sign. I'm going to go to the next construction plane, which is this one. I don't have to turn it on, I can see it. But here, I'm going to right click and go to create sketch. Okay, so I've got another sketch here, and maybe this approach isn't the best for machining, but we're going to do it anyway. All right. So in this one, I'm going to create another polygon. I love it when I kind of realize when I've actually made a faux part to begin with, but I'm going to continue. All right, so I'm going to create another polygon. I'm going to stretch that out, and it's going to be smaller in this case. It's going to be smaller, and it might be even a bit more skewed. And this has got, I don't know, well, the other one has 7 sides. This one I think could have maybe 5 sides. I'm going to say it's 30 mil in diameter, well, from its flat to its flat. And then I'm going to say it's got, oh, I don't know, there's 3 of them, 5, 3, 2, 1. In fact, I'm going to say that, yeah, no, I'm going to say that's 7 sides. Reason being is because I'm going to re-edit the first one late in a minute, right? Let's not worry about it, it's not important. That's cool, I've created that. I'm going to go finish sketch. And as you can see, I've got 2 sketches. They are parallel to each other, but they exist 25 millimeters apart, right? So let's go and do plane XY plus 50. And in here, you've got it. I'm going to create another polygon because I'm that interested in polygons. So there we go, slap it in there. And this one I'm going to say is, I don't know, 20 millimeters, and I'm going to say it's 5-sided. Right. Finish that sketch. Got 75 mil, and I'm just going to do this as it goes along. All right. As I say, you could create any shape, but as you notice, I've created really simple shapes for demonstration purposes. Now, when it comes to you creating an object, you can be as complicated as you can be as complicated as you want. All right, it's up to you. It'll be interesting to see what kind of results you would get. So this is a 3-sided polygon. And what you might realize about 3-sided polygons is that you can't, or polygons, is that you can't have anything less than 3 sides. Otherwise, it's a line, sort of, or it's an open curve. All right? Ooh, yeah, it's quite big, that. Go back to there and change that to bigger. There we go. finally, we've got this one at the top. And in there, I'm just going to put a circle. About 10 mil. All right. Brilliant. So I've created 5 different sketches there. In the browser, under sketches, open that up and it's sketch 1, 2, 3, 4, 5. You can call it that if you want, but it's nonsense. So I'm just going to name them all because I'm really, really crass like that, or only attentive. So this one's poly 9. It hasn't got 9 sides yet, but it will do. 47, and so on and so forth. Bless you. 7, 5. Now, I don't know if everyone's updated their version of Fusion from last week. I updated mine the following day, last Thursday, and sure enough, I had exactly the same features that Ian had in his version. In fact, Fusion updated itself again today. So maybe it's doing it on a week-by-week basis. Bless them. Okay, and finally, this one isn't a poly at all, it's a circle. I'm just going to call it a circle. I would usually give it a measurement as well, but important. Right, there we go. Now, as I mentioned earlier on, I want to change the side of this polygon here. Anyone could suggest how I would go about that? How would I do that? Well, the answer is this. I would go down to the bar at the bottom, and this is where I've got my history, my parametric history. If you haven't got that, then where is it? Then you have to click on the very top of the browser, and then you have to go to. I've got it will say capture design history. You don't have to, in which case you can't then change stuff. Right, but I've got mine turned on. So I want to go to that. I could either click on that to go edit, or again, I could just double click on that. And in this case, I'm just going to redraw that polygon. I was hoping that I could just change the number of sides, but I guess Fusion isn't quite as sophisticated as that yet. Okay. Sweet as a nut. There we go. So for each time that's going to extrude or loft through these points, it's going to be missing an edge or so, all right? So to do this, once you've got all your sketches, your collection of sketches, go to create, and then we're going to go to loft. Now, I'm sure I've shown you this before, or it's been shown before, but this session, we're going to look at it a little bit more closely. So in this case, I'm going to select the bottom one, the one above it, the one above that, and the one above that. All right. And sure enough, got this. Oh, it's strobing. Oh, I better collect that very top one. So we've got guide types, which is rails, and those can be the edges, or we could select it. Well, we could select a rail. We haven't drawn one in, or we could use center line. It's kind of weird that it's that color. I know why it is that color. It's because, I'll go into that later. That's under inspection. Okay. We have a choice of connected or direction. I'm going to just go with connected actually. And it's going to create a new body. Closed. Now you've got an option of closing it. Won't like that, but we'll keep it open. Okay. And sure enough, I've got a very kind of funky shape here. As you can see, the edges that get lost get swallowed up within the various different layers that inform this sketch. Okay, so I'm going to call that Don't really know what that call that. I call that blancmange. That's spelled blancmange, right? We haven't. If you don't know what blancmange is, it's some kind of jellified custard. All right, so there we go. Now the thing is, if I was happy with this, I could thereby machine it. But in order to double check that it is the size and the scale we want it, we're going to inspect it. Okay, so we're going to have a look at inspection. Now, usually it's a good point to save. I haven't saved it because I'm being belligerent. So I will save it because it would be a terrible shame if I lost it. And my laptop's been getting really hot today, and I daren't lose stuff. So in this case, it's milling examples. So I'm going to call it, I don't know. All right. So there we go. Now, the thing is, we're going to have a look at this by inspection. And inspection is important, particularly when it comes to making sure we've got the right dimensions to fit our block of material. Because bear in mind, our block of material doesn't actually exist. It exists in the virtual world, but and in my head, but I haven't even cut that material yet. So what we're going to do is we go to inspect, and inspect can be found next to construction. And again, it's got a drop-down menu. And inspect is really useful, especially if you are designing stuff that has things that are hidden that you can't see. It might have internal structures. Okay, so, or you just want to measure something. So the first thing is measure. And so we've got this dialog box here. Okay, got selection filter, faces, edge, vertex, select body, select component. Well, this is a body, but we want to measure particular aspects of it. Okay, so I'm going to select face, edge, vertex. I'm going to select this face here, and then I'm going to select this face at the bottom. And it tells me it is 100 millimeters. Well, that's good because that's what I needed it to be. Okay, and it says results, and it says it's 100 millimeters at the 0 degrees angle. Gives me an area, loop length, and it gives me the area. So that's the area of the top of that circle, and then it also gives me the area of the bottom, or the loop length, the closed loop. Quite handy, really. Okay, but what if I want to measure something else? What if I want to know how, like, the dimensions of one of these faces? Well, I go to inspect again and select one of those faces, and it tells me the area of that side, and that area is 2029.292. It's a lot of 2s and 9s in there. Funny that, isn't it? Okay, and the loop length of 250.9. Brilliant. Now, as you can see, I came out of that tool and then went back in there. You don't have to do that. There's a restart button there. And do that instead, so I can select the point next to it. Okay. I can do multiple selects too. Well, it usually only wants you to do 2, not any more than that. So that's the inspect button. But there's a really useful feature with inspect. That's the measurement button, but there's other useful features. And the particular one I'm interested in is the sectional analysis. And sectional analysis is actually important. So here, I could select a face, but if you're going to select faces, they have to be planar. That means they have to be flat. All right, so I could select this face at the top, and I could just pull this down like that, and that shows me the cross section, and they mimic the different shapes that we use to create it. So boom, there we go. We've got that 5-sided polygon at that 50 mark. Remember, I'm measuring from the top down, so it's minus in this case. Minus 75, 7-sided, and of course minus 100 is that 9-sided object. But it just goes to show the path that it can take. Sectional analysis is super handy, super handy. So if I go, I can go from color or custom. Yeah, yellow, lovely. All right, I've gone okay. It's like, oh, where's the rest of my model? It's in the browser. So in the browser, there's something under origin, and it's called analysis. If I open that up, there it is, section 1. I would usually give it a title, but I can't remember where that is in the order of things, but it doesn't matter. But I can turn that on and off. You can create more than one section, but you can only display one section at a time. So I'll do that again. So sectional analysis, I'm going to use whatever plane that is. That looks like the X and Z. And this time, we can get a cross section through the other way. Very funky. I like it. Now, not only can you create it planar like that, you can also rotate it. So there's a little rotation tab there, like that. So you can rotate it through, or even the other way, like so. Okay, right, so that's all well and good. I've created the shape. It can be machined. Now, the thing is with Fusion, we can output directly, sort of directly, we can output machine files from it. The problem is, though, in doing that, it is actually a really advanced type of thing to do. I can show you it, which is here. It's called manufacture. And there it is. And it's got milling. We've got tools. These tools here, we're going to go milling. The problem is you need to have an understanding of milling to use this. And if you've never done any milling before, you're going to get really stuck. Now, unlike 3D printing, whereby generally not much damage is ever done to a 3D printer because 3D printer software is really savvy when it comes to it, with milling, it is really easy to damage tools, materials, and the machine. So we're a bit cagey about letting people do it. Although if you're experienced enough, you certainly can, not a problem. Now this is a 3D object. So there we go, we can select one of these tools. But first we want a setup. Oh, we've got setup here, there it is. And in there, I'm going to say parallel, I'm going to say adaptive clearing. Now, what I'm going to talk about in the next, not the next session, because this is it. In the second part of this session, I'm going to talk about things called roughing and finishing. What it means is that with roughing, you remove lots of material quickly. Finishing, you get all the detail working. But generally, you use adaptive clearing for roughing. You can use it for finishing, but that's not it. Now, the thing is, I've selected adaptive, and it's brought up this toolbox here, this dialog box, and it's got all sorts of information in it. This is why this is more advanced stuff, and it's just not covered. I'm not even going to bother really covering it. I'm just going to try and demonstrate it. But here you've got the tool. You select the tool. No data. Well, let's find the tool. Probes, taps, turning, tutorial, sample borders, profile tools. Well, we work in metric. I've got nothing in my library. Oh, well, let's have a look. Flat end color covers, all nose cutters. God bless Fusion, yeah. So like literally just sampling tools. There's nothing there, Ian. Bloody heck.
Yeah, last time I went on Fusion, it was in a completely different place, and I think I might have had to go to the top really and have a look at one of the top tabs. Perhaps I'm not quite sure what was there, but it's moved the library.
It doesn't matter. I've got another bit of software to demonstrate this on. I mean, it does matter. It matters a lot. So it means I can't use it. Set up. Set up. Box point machine. Machine. Auto desk generic 3-axis. So that, yeah. Okay. On that milling operation. Model orientation box point. Yeah. Set up 2. Tool. Oh, here we go. The cute. Oh, it's all in Metch. It's all in Imperial, which is like not handy for no one. What's that? Corner radius. Yeah. Who would be machinist? I don't know. So we'll select this one, 10mm tool, and then it gives you a selection of materials. Well, I mean, as you can see, polystyrene isn't there because it doesn't believe you do it. Well, it's plastic, so we'll go finishing. I mean, it's not finishing, but we'll select that. Okay. There's our whacking grate tool. What you notice is that it's too long. This is why I'm not really going to go into too much detail, I think. Oh, man. And, yeah. Edit. Spot drill, cutter. 3mm, 90 degrees, shaft diameter, yeah. Overall length, I'm going to say it's 120mm. No. All noise. Oh dear. I feel like I'm flogging a dead horse here, so just to let you know that. Overall length. Okay. Shaft, yeah, no shaft, holder. Cutting data, speed. Yeah, this is a whole like 6 weeks session on itself. 4,000 RPM. The reason why that's 4,000 RPM, well, I don't particularly, it's just I know that the machine that I'm going to use goes up to that. Our CNC router, which is also a new machine, goes up to 24,000 RPM. So that's the one we'll use. Select. All right, there we go. Okay, and then it's got geometry. Right. I don't want to bore you senseless. I feel like I'm out of my depth here and showing you so quickly something that I don't know. I feel like I don't want to give up though either. Passes, one pass height, retraction height. Yeah. That's it. Bottom, cool. Simulate, generate. So what happens is that you create the file, you choose your tool, and then you have to generate. All right. You have to go to generate, and then you can do a simulation. And as you can see, it's forming these different toolpaths. So what happens is, like 3D printing, it takes your model and it chops it up into layers, pop, 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 pop. Okay, and then for each layer, it decides the path of the tool. In this case, it's a spinning tool bit. We'll look at that a little bit closely in this second part. Okay, so it's done that. And here I'll go to actions and say simulate. It's got solid block there, and I'm going to say start. Oh, hang on a minute. Viewpoint model. Stop. I want it to remove material. Toolpath before, show links, show leads, show cutting motion, stop, fast, plastic, transparent. Let's see. Hello. Well, that was a bit too quick for our liking. Let's see. Okay, not such a great demonstration, but I think you might get the gist. The bottom line is that when you use this for that, and there it goes, you go to actions, and then you would save this as post-processing. Okay, drop that down there. There's your tools, and you go post-processor. All right, let's just drag that onto the screen. All right. So in here, this is where we would save our file, and this is produces something called NC code. It's numerical controlled. So milling is known as CNC, machining, computer numerical control. And then this just outputs a whole load of coordinates called G code. Now back in the day, G code would be programmed by hand. You would devise it by hand by writing down a lot of numbers and coordinates. it was a very painful process. All right. So there is a bit of machining and creating a file in a nutshell. But what I want you to do is create a different type of file. Now this is a solid, okay? But the thing we're going to do is create a surface. As I mentioned earlier on, with surfaces, you can machine them because it acts as an active boundary. Now I used to demonstrate this really quickly in Rhino, but this isn't about Rhino, this is about Fusion 360. All right, so I'm going to create a new document. I'm going to say blancmange. I'm going to create a new document, which is up here. I've got the blancmange. I'm going to go new design. Now this time, I'm going to use two different plane directions. I'm going to use one to set the boundary that I'm going to work within, and then I'm going to use another one to set the boundary of a curve. This is going to be possibly a bit easier, and it's going to use things called splines. Now we looked at splines earlier on, and if I remember rightly, splines come from, I might have mentioned this before, but splines come from the boat. They come from the boat building business, naval architecture. So back in the day, when you wanted to create the shape of a hull, you had to have one-to-one scale drawings, well, because you couldn't emulate those shapes so easily. Then someone came up with a bright idea of a spline, which was a flexible piece of wood between two pins or three pins, and it would follow the path of least resistance and thereby give a really beautiful flowing curve. Okay, so I'm going to create a top sketch, and in this top sketch, I'm going to use the point from the middle. This is going to be the boundary. I don't really need to do this, but sometimes it's good practice to do. So a boundary, I'm going to create a center of rectangle, just like before. Draw that rectangle, and it's going to be 100 by 100. Okay. There it is. Finish that sketch. Feasibly, I could actually create a cube. I don't want it to muddy the waters too much in terms of what we see. All right. Now, these construction plans that we're going to create, we're only going to create like maybe three. We'll create 3 construction plans to keep it simple. Or in fact, we'll create 2. Okay, so we'll have one in the middle, which is an origin plane, and 2 either side. Okay. So I'm going to go to create sketch, and I'm going to select this one here. This is the right plane, otherwise known as the Y and Z. I'll rotate that around, you can see it clearly, so I'm going to select that. And so sure enough, that edge of that square that we created is just now a line. You cannot perceive that it's actually got a 2-dimensional form. Well, it is 2-dimensional, but it's got a shape. Okay. And in here, I'm going to create another square, but in this case, well, firstly, I'm going to create points. It's always about the points. Point in the middle, and then I'm going to create a point to one side, to the left. There it is. Now, I want to make sure that those points are accurately distanced. So in this case, I will use the sketch dimension tool. And I'm going to, when you use the sketch dimension tool, select the thing that you want to measure from, not to. Okay, so I'm going to select that one. Because if I measure to this point, it will move it. If I measure from it, it means it will keep it stationary, particularly if I locked it in place. And in there, I'm going to type in 50. Right? The all-important thing about points. I'm going to create another point, and this time it's going to be on the opposite side. But I'm going to create 2 points in a minute. And again, I'm going to measure that from the center outwards. And this one's going to be 50. Didn't really have to do it this way. I could have done it another way, but I'd rather show you the long way sometimes. And then I'm going to create a point upwards. And again, I'm going to measure that from that point at the bottom to to this point there. And in there, it's going to be 100. Right? Reason being is that I'm going to create a rectangle. Now, I didn't have to do it like that in points. I could have, I've done it like that because it's then constrained. But I could have just used a 2-point rectangle. So I'm going to go from the left-hand point at the bottom all the way up to that top there. And as you can see, that square that we formed is indeed 100 by 100. In fact, I would have thought it would have been constrained. But I suppose because I didn't add any measurements, it isn't. But don't worry about that. That's fine. Now, the thing is with this, its sole purpose is as a guide. It is not there to be extruded or anything like that. So if you've created that, I want you to select them features, go over to the sketch palette, and like before, turn them into a construction like that, that brown stippled line. Okay. And the thing is, we're going to do this for, are we going to do it for every box? Yes, we are. So every plane that we create, and there's going to be 2 more, we're going to recreate this, but we'll do it by projection. We won't have to draw it out again and again. So we've done the donkey work, as so to speak, the hard work here and now. Okay. Now, while we're in this sketch plane and it's the middle, I'm going to select spline. I'm going to go to create, and you can select spline, whichever spline tool. But a word of warning, do not create an overhang. I say that every time, whenever I demonstrate, whether it's Rhino or Fusion, I say do not create an overhang. People always create an overhang. If you want to do that, that's fine, but it will have potentially undesirable results. It's up to you whether you use fit point spline or control point. I'm going to use control point, and I'm going to find the edge, that edge there. So, and anywhere, it doesn't matter where. I'm going to do it sort of highish, and I'm just going to make this sinusoidal shape. Oh, I nearly had an overhang there. And I'm going to locate it against the right-hand edge there. I'm going to go OK. I'm going to press escape, and that gets me out of that tool, so I'm not using it anymore. So I've just got this arrow. And if I click on it, oh no, of course, yeah, I can drag the points in, drag it around a bit, make it a little bit more user-friendly. There we go. All right, so I'm happy with that. I'm going to go finish sketch. Now, if you want some time to do that, please say. As I said, it's the spline tool, either one, and just create some kind of sinusoidal curve. Go finished. There we go. I've got the other sketches on, and as you can see, that's how it exists relative to that. All right, so we've got one sketch, want 2 more. And to do that, like before, we're going to create construction plane. Here we go. An offset plane. So I'm going to select that plane, which is parallel with this, which is this one. I'm just going to select that. Now, the thing is, I could drag that out, and I know that half of 100 is 50, but I don't have to do it like that. You see, in the offset plane box, there's something called extent. And I could go to object, and that object could be a point on the corner. So if I go like that, boom, there it goes, it's done it. And it tells me how far it is, 50. That's good enough for me. So I'm going to go OK. And while I'm at it, I'm going to create another construction plane in the opposite direction. And I'll go to object. There we go. All right, so anyone know what I'm going to do next? Okay, so what I'm going to do is I'm going to draw another sketch on one of these construction planes. Yes, I could label it, but in all intents and purposes, I'm not. I'm loath to, but I will do because it's good practice. And who am I to teach bad practice? XZ. This one is minus 50. Reason being is because it's coming towards us, not away from us. Said minus 50. Okay. And this one thereby is XZ plus 50. Oh, grammar. Z plus 50. All right. It's going to be bounding box. And this one, I don't know what to call this. I suppose I'm just going to call this spline XZ 0. It's in the middle. All right, so I'm going to start with this one first. I'm going to select it in the construction plane, and I'm going to go create sketch. And as I said, well, I haven't said anything, but as you can see, the sketch behind it is still there. I've turned it on, off. I'll turn it back on again. The reason being is we're going to steal information from it, not steal it. We're going to extrapolate information. Turn that plane off so it's out of the way. So we're in sketch mode, create, project, and I'm going to just select geometry. Of course it won't let me select it. Why would it? Oh. Of course it will. So here we go. So if you use selection filter, there's no bodies there. If there was a body, you could take that information. But specified entities, so that one there, and that one there, and the one on top. And why not the one on the bottom? I'm going to select that one on the bottom. As you notice, when you're doing projection, sometimes you can't really see what you're trying to get, your grab. So put it in perspective mode so you can see what's happening. And once you've done that, put it back into that field of view, that straight on field of view, in this case, right. Okay, now I'm going to link these projections. The reason being is because if I change the bounding box of one thing, it will change it for the other. Generally, I don't do that, but in this case, I want to because I want them all to stay the same. All right, so I've got a box here. I'm going to select all of that, and I'm going to turn those into construction planes. As you can see, it's purple, even a purple stippled line, and that means it's a locked projection. Okay, I can unlock that, I think. Well, maybe I can't. It doesn't matter. It's not important here and there. Pretty sure you can. But in this case, I'm going to create another spline. I don't have to create splines. I could use lines, like straight edges. I'm not going to. I'm going to go for the more gentle and flowing look. So again, I'm going to use that spline tool. I'm going to use fit point spline this time. And I'm going to start on the left again. I'm probably going to go in roughly the opposite direction. Right, if you could just see what I just saw a little wagtail. So if you don't know what a wagtail is, it's a small bird. I couldn't help but notice. Okay, so unlike the spine that goes through points, you don't get these handles on it, but you can move the points to change the shape. If I get out of this tool with whatever that's called, fixed point spline, not fixed point, fit point spline, I can adjust the handles. And that's handy because we don't want that overhangs. That is a no-no, okay? All right, I think I'm happy with it. Let's make it a bit more radical there. Yeah. All right, I'm okay with that. Change that name. Spine XZ minus 50. Yum. Right. Put it into perspective mode. You can see what's going on. In fact, that's plus 50, not minus 50. Oh, whatever. Don't matter. As long as it tallies with the construction plans. And finally, we're going to create this last sketch here. Create sketch. And again, we're going to steal that information, but I'm only going to steal it from one sketch. I'm going to steal it from the original sketch. In fact, it didn't even save that. So here we go. Project, grab that one, grab that one. That's interesting. Fascinating, fascinating. Grab that one, grab that one, grab that, yeah. Project, beautiful. Back into that viewpoint. Select all of those, turn them into constructions. So you can't use them. All right, and then finally, yet another spline, if you want. Up to you. I'm going to turn that other spline on. The reason why I've got these other spines shown, so we can see what's going on. It's going to influence how I create my other shape. Doesn't have to, it's not important. It's just how I'm going to do things. All right. While I'm at it, I'm going to name it. Right, is everyone following this? I do apologise if I'm rattling on, so to speak. 50. Right, how are we doing for time? Well, we're coming up to a break. Coming up to a break in a minute. I'm just going to finish this. There we go. So we've got our 3 sketches. Okay. Now the thing is, we can't use this in solid mode, and the reason being is, obviously, if you were sitting here, actually in the room, I wouldn't pick on one of you, but I'd actually directly ask you, why can we not create a solid from these 3 sketches? Anyone? Why can't we create a solid from the 3 sketches that I've drawn, or you might have drawn?
Is that because there's no plane? There's no surface for it to create it. It's
No.
just like,
I mean, it is to do with surfaces, but it's not because there's no plane. They're all on a plane. Now, I haven't lofted it yet.
Yeah, Roland just said it's surface.
It is a surface. And what is a surface? The surface is generated by what? Not by lofting, but what are these? I've drawn these curves, right? What don't curves have? Curves do not have what? They're like vectors. They have a direction, they have a magnitude, but they do not have this very important thing. They don't have a thickness, okay? They have no deceivable thickness, and so thereby, you can only create something as a solid if it's closed curve, like a circle or a square, yeah? Because these are open-ended, you will only ever create surfaces, all right? And that's the reason why you cannot loft that as a solid. I can give it a go, and I will, but yeah, look, it won't even select them. It's like, nah, don't be silly. So in this case, we'll go to the surface tool, which is to the right of solid, right near the top of the screen, where everything is in this delightful kind of peach color. I'm going to go loft, and then I'm going to select these. Okay, so I've lofted that, and as you can see, we've created this surface here. Rather delightful it is. Takeoff weight. Let's change that. Let's change that to 0.5. Yeah. Let's change it to 2. It gives it more definition. Well, I don't like 10. Often with tools in Fusion, I push them sometimes. I push the envelope of how much of a radius we can have. Okay, so I've got that. I'm kind of happy with that. I'm going to go OK. And sure enough, in the browser, under bodies, we have a body. It's called body 1. I'm going to call that flow surface. Flow surface is a bit poncy, really. Loft surface A. Right. Let's save that. And it's at this juncture. Blanket. Let's call it blanket. At this juncture, we're going to take a 10-minute break so I can make another cup of tea and try and get that damn machine working. All right. So I'm going to start. I'm going to reshare the thing, the thing that I've created. Screen number 3. So, okay, we've got this. We have what is otherwise a piece of, what could be a piece of fabric. Now, there's a couple of things we could do with this because it's a surface. Potentially, not guaranteed, we could thicken it. So this is all under surface. So I went to create, I went to thicken, faces, select, boom, there we go. And I could thicken it in a direction, maybe 2 millimeters. Maybe not. Doesn't always work because this is Fusion. If there was another bit of software, you could potentially extrude it. No, it doesn't like it, so it won't do it, which is a shame. Actually, maybe if I flipped it, maybe if it was the other side. No, it doesn't like it. It would collide. But okay, so it doesn't matter because the bottom line is that this can still potentially be machined. Okay, if I go to body, or if I go to the browse on the left-hand side, go to loft surfaces, A. If I right-click on that, I can save as a mesh. Now, this is where Fusion has changed in the last 7 days because it would normally be save as an STL, but now it's save as a mesh. And sure enough, I can save it as a mesh. So I've selected save as a mesh. Format, 3MF. We're not saving it as a 3MF format. That is a format for like 3D printers, like Ultimaker actually, .3MF, 3 manufacturing. We would have a choice of STL binary or STL ASCII. We don't select ASCII, and the reason being is it generates massive files that are a lot larger than binary, but yet provides near enough the same information. I did read up a while back what the difference was between the two. I just can't remember. It's just not important. So yes, I can upload this. So I will save it. Binary. You can't send it to a 3D print utility. It won't print. Well, you can. You can have a go. I'm going to go OK. Oh, planters. It's not there. Let's have a look. A massive collection of files. So I'm going to save it somewhere where I know. Milling. There we go. Loft surface. I would create another folder, but it's fine. All right. So there we go. That's now stored on my laptop as a mesh. And that's going to go into another bit of software, which you haven't downloaded, you haven't really got access to, and it's called SRP Player. An SRP Player is used to generate toolpaths. SRP Player is very much like RD Works, and it is like Cura. It is otherwise known as a compiler. And so what it does, it takes your design and it compiles it into machine code, okay, NC code. We'll have a look at what that is in a minute, as interesting as it is, and we'll have a look at it. But before we'll do that, we're just going to continue with this. I haven't finished with this yet. And the reason being is that, yes, I could machine this texture, but that's not enough. So I'm going to look at it in the top view. I'm going to go to create sketch. Of course, I can't see the down. Oh, yeah, there it is. So I'm going to select the top sketch plane. All right. And here I'm going to use lettering. All right. All right. Well, before I do that, I'm going to turn the body off first because it's in the way. I'm going to put center point there. And again, I'm going to create that rectangle. There we go. And in here is going to be 100 by 100. Okay, brilliant. So I'm going to turn that into construction. Now within here, I'm going to go in create, under create, there's a tool, it's called text. Now we looked at it the other week, and I think Ian looked at it last week as well as I had the week before. So we're going to look at it again. And here it's going to be type. Well, I'm just going to type in text. It could follow a path, and that path could be a curve or even a construction line. That's not important. So I'm just going to say type text, and I'm going to draw a box. It says, in hopes, There we go. And in there, we should be able to put a text. And I'm just going to put, I don't know, SCP, because we're super into it. There we go. Smack in the middle. And I'm going to make that a lot larger. How much larger? I don't know. 30? Would that be? Yeah, that's cool. SCP. All right. I'm happy with that. Okay. Big deal. So what I need to do now is hover over those letters, which are now highlighted in a darker blue, right click, and I need to explode it. Because now they're in green, i.e. they're, some would say they're locked, but they've been broken and fixed, and we can do stuff with them. And that's exactly what I'm going to do with them. So I'm going to go to finish sketch. Now, the thing is, this is on that bottom plane there. Just change the name of that. SCP X10. Right, it's on the bottom sketch, bottom plane, and then we've got our lofted surfaces way up there. Well, that's okay. That is okay, right? Now, is it going to let me do it? Yeah, it's going to let me split that face. But before I split that face, I need to do something with these letters. So we're going to extrude them. All the way through. Boom. There we go. All right. And you might think, oh, what's that all about? Okay, so I'm still working in surface. I probably could work as a solid, but it doesn't really matter. All right. So I'm going to go new body. And the reason why it's got to be a new body, or a new component, well, it can only be that. But like if it's in solid mode, it would say, oh, do you want to join it or delete stuff or intersect? I don't want to do anything of the sort. We're going to use these letters, and it's essentially like a biscuit cutter, okay, or something like that that creates a form. It's going to be a die, so to speak. So I'm going to go okay. And as you noticed in bodies in the browser, I've got body 2, 3, 4, and 5. Yeah, I mean that's great, but as I said, I'm a bit crass like this. I'm going to right click on body, and I'm going to go new group, and I'm just going to call these letter surfaces. Right. Now a couple of weeks ago I showed you how to move these bodies. Like, I mean, I could select them, these ones, and I could right click and go move to group. Alternatively, I could just drag them and drop them in there. All right. So in there are those letters, all in a nice safe place. That's brilliant. However, what we want to do, what I want to do, is do some modification work. So under here, modify, I'm going to go to split face. And it says divide faces using a selected profile face or plane as a cutting tool. Select the faces to modify, then select the profile face or plane that divides the source face. All right, faces to split, well, it's only one. Splitting tools. These guys. Go. Split with surface. Split along vector. Split close. Split surface. Extend cutting tools. Don't need to do that. I'm going to go. Okay. All right. Where is it? All right. So I should theoretically have these tools. Curiously, though, I'd like to move them. Ah, interesting. Right. Move. Oh, how disappointing. How disappointing, Ian. All right, so I'm going to go back a step, because that is not what we want. And as you can see, sometimes, something I don't do often, do it in Rhino a lot for demonstrations, but sometimes you have to go back a step, try a different way. There's nothing wrong with that. People do get flustered by it, and this is live, and you think I would know better, but I don't. So we'll have another go at that. So what I'm going to do, because obviously it's asking me to, it wants me to do it, I'm going to make a copy of the surface. And actually, it makes sense, because what I'm going to do is offset the letters anyway. That's what I wanted to do. So I'm going to go create copy and move. Not that way. I'm not going to do that. Go up, and I'm going to move it like, I don't know, 15 millimeters. I'd ask, but no one seems to be forthcoming with numbers and shapes. But that's okay. Right. All right. So now I've got that one.
Sorry, Owen, can I ask a question? Did you have the chance to select solid during that process?
What do you mean?
When you offset the surface, do you have a tick box on there just to click solid?
Ah, yeah. Well, I'll show you.
Just a thought.
So yeah, I mean, you can have bodies, faces, components, or even sketch objects. So I mean, this was a face, but it still worked. But as you can see, if I select that, this is made up of numerous faces, and as you can see, the directional information is not where I want it. So that's why I selected as a body. It says selecting it as a body. All right. But yes, you do have the option, any kind of move. And because that move function, it transcends the tools from surface, mesh, even sheet metal, form, and of course surface. Okay, so we've got two surfaces. I'm going to select the top one, which is called surface A, loft surface A, brackets 1, brackets 1. All right. And now I'm going to use these sketches. And this time I'm going to extrude through it, apart from that guy there. And instead of new body, I'm going to create an intersect. And sure enough, what this demonstrates in a really long-winded way is that there are many ways of doing things in CAD, but sometimes there is only one correct way. I think that was a really good example of that being the one correct way of doing something, because that's what we want. Okay, so I've got these lofted letters, and now I've got the loft surface. So I've got this, right, and they are floating in air. So the idea is that I want to export this as a complete set of meshes. For a second there, I was a bit worried that Fusion wouldn't let me do that, which would show a massive flaw and thereby a limitation. But if you want to export something like a mesh en masse, you have to go to that component, that individual component. So I went right to the very top. I'll show you. To here, SCP blanket version 1. And then I right-clicked on that. And then that will let me save it as a mesh. Not just one item, which I was trying to do, like a doofus, but en masse. There you go, Ian. There you go, peeps. All right, so I'm going to say this is lofted surface B. All right. Save. Okay, so that's that. Big deal, you say. I'm going to stop sharing that after I've saved it. Cool. Okay, it's just me again, drinking my cup of tea. So what we're going to do, I'm going to open up another bit of software. It's already open, and it's called SRP Plan. It's made by Roland. And Roland are a Japanese company who not only make musical instruments, amongst other things, they make software. They make printers and milling machines. And generally the milling machine behind me, which is a Roland, has been pretty damn bulletproof, but it's got a USB issue. It might, well, I don't know what that is. And I've tried reinstalling it. It's probably a firmware thing again. So what I'm going to do is I'm going to present another screen. And this is it. Oh, where are we? Where's my mouse? And this is called Roland SRP Player. It doesn't do much, but it does work at machining paths. Okay, And what I do is I go to File. These are my things that I've machined. I'm going to show everything because there's many. And I'm going to go to Open. And let's go and find it. Data. CAD. P. Charts. And we can select either one of these. I'll show you surface A first. Okay, so it's important that. All right, and there it is. Please don't tell me that you've run out of blinking memory. That would be a travesty. And I can rotate it around. All right, now the thing to notice, if you can, is at the bottom, there's our friendly and familiar, I say friendly, our familiar axes, the X, the Y, and the Z. If you note, they are denoted in the same colors as you would find in Fusion 360 or Rhino or any other bit of software. Okay, if I zoom in to this object, you can see the individual vectors or surfaces that make up this thing. All right, like so. All right, so big deal. I've got a surface. That's lovely. Over on the right hand side, this is where everything happens, and it's really systematic. So it says the size. I can change the orientation. I say, oh, I want to machine that way down. Remember, I'm machining from the top downwards in this direction. All right, but of course that's nonsense. That's hokum. I've got to machine it in that way. All right, and we'll have a look at it if what happens if we try to machine it in that direction. We could rotate it around the Z-axis. I'm not going to bother doing that. And we just go to type of milling. Better surface finishing, faster cutting time. Let's do that. Model with many flat planes, model with many curved surfaces. Well, it is that. And we're only going to cut the top only. We could do the top and bottom. However, it is a surface. There's not much point. Then we're going to go and create the toolpath. And in here, it asks us, like, well, what material do you want to use? And yes, I can input my own materials, but you've got things like styrofoam, sand the door, which is, I don't know if you can see the small window of me, but this stuff's called chemical wood. It's epoxy-based resin, really good to machine. It's filthy material though, because it is microplastic. Soft woods, chemical wood, soft, hard, modeling wax, woods, cork, plaster, polyacetal, polycarbonate, acrylic. There is also aluminium, but that seems to be missing off here for some bizarre reason. It can also do graphite, but I don't know, it's just a bit weird, it's not on there. Oh well, whatever. So we're going to go styrofoam. As you might notice, the size of our block is 100 by 100 by 100. But it always wants to make it bigger. It always wants to have a margin around the edge, and that's fine. So sometimes you have to lie a bit, and give it a margin that it doesn't have, and that's exactly what I'm going to do. Thickness, I'm going to say 100. Now, the thing is, once I click here, we could center that model, like so, or we could have it align it to the top. And curiously enough, it won't align it to the bottom. I think, oh, yes, it did. Look at that, blind. We're just going to align it to the top, right? Near enough, anyway. Actually, I'll do it to the center just for the sake of it. So, create toolpath. We can't do that yet because we haven't inputted the information. The thing to understand about milling and machining, and this is the thing, I'm just going to stop sharing this for a second and present me. That milling tools come in all sorts of shapes and sizes. I'm going to apply them here. So, because this has got lots of curvatures, I would use something like this. Ooh. This is called a ball nose cutter, and that's got a radius going all the way around it, like so. Okay, so this is really good for curved objects. And the thing to understand about the milling machines, the ones that we have, this tool is in this plane. If I can get that focused, I don't know, it's a bit weird, that, isn't it? So it moves in this direction, up and down. As it spins in this direction, and as it's spinning, it just removes material. This is really, really, really sharp, okay? It's one of my own personal expensive little tools. Okay, so that's a bullnose cutter. And then you've got things like this, they get a bit bigger. Where am I? Oh, I'm there. This is called an end mill. This has been used for plaster of Paris since it's got white on it. And as you might notice, if that was a profile, that is dead perpendicular at a right angle to its length. There, I've got to be careful. It's really sharp. It's really good for taking skin off the. This is the front of the hand, by the way. That's the back of the hand, front of the hand. All right. Really good at taking skin off. Really sharp. Needs to be sharp. Now, you do get variations on cutters like this. They have slightly rounded shoulders, and that's called a radius cutter. Not to be mistaken with a bullnose cutter. Now, as you might appreciate, they come in different diameters. Oh, there's another cutter here. All right, that is an engraving tool. We wouldn't use this in SRP Player. We would use this in another bit of software, something like something called Aspire, and that's for CNC routing, which is very planar for creating. I haven't got anything. There's a table yonder, but you can't see it. All right, I might show it to you in a minute. But they come in different shapes and they come in different sizes. So that's like probably one of the finest cutters. It's not the finest cutter, right? It's the finest cutter I've got to hand. That is 2 millimeters in diameter. Now cutters can go down to 0.01 millimeter. That's really small. What you have to understand is they are very, very short. Okay. And that is a clue to the kind of things you can machine, because this thing that I've got on the screen that we've looked at, that I've created, could I machine that with this tool? The answer is yes, but only so far, because there's only that length of tool, and half of that has to go inside something called a collet, and that holds it. All right? So yes and no. So when you're designing stuff for machining, if you're designing molds, you've got to make sure that your tool is long enough for the job that you want it to do. Or you are smart enough to be able to extract things out of a machine that it can't really do. Hence, with this, I had to lie to the machine so it could do it. You have to be careful. And the reason being is that when you are milling, you get things called tool collisions, and they are bad. You destroy the machine, damage the machine, destroy the tool, and ruin the workpiece. And considering that some of these tools are actually quite expensive. I mean, this one's like 80 pounds. Yeah, so it's probably about 80 euros. And that's cheap, considering that a tool like that, if it's diamond tipped, if you want to do things like glass, that can cost you thousands. So you've got to be careful. I don't want to use that, so. All right, so I'm going to share that screen again. What are we doing for time? I think we're doing all right. Share a window, share an entire screen. What's it? Share. Okay, so we're back here. And unfortunately, I've got a screen here. This bit of software on well, it's not on a 4K screen, but actually it's quite. I can read it because I've got a 4K screen, and this is a spare monitor. I can never read things that, let's say, roughing. So we've got roughing, and roughing is identical to finishing in many ways. It's got the same kind of parameters, like, you know, it's got the top surface that you want to cut. It's got the modeling form. Well, I could cut the front if I wanted. I mean, it's not going to let me, but that's fine. It wants to add a margin, hence that's why it's bigger. And usually you add a margin that is a reflection usually on the tool diameter that you're going to fit. It needs to be bigger than the tool diameter. Otherwise, your tool will get to the end of that block and it won't go any further. So you might not end up machining the edges. Okay. And we've got the cut area, as you can see. That's all of it, but we can do partial cuts as well. Like so. I might just want to machine that bit, or I might want to machine that bit in a different way from the other bits. Of course, I'm not going to do that, so we'll just have all. But you can input that information in here. The thing is with software like this, it can get a bit confusing what the lower X is and what the lower left X and the lower left Y is, and the upper right X and the upper right Y. It's kind of like garbage, really. It's like you have to move it to see what it's doing. What I do, I've got some kind of weird dyslexia with it. And then we got depth. Yes, that's fine. Now, the thing is, what's to bear in mind is that I could cut potentially all the way down the whole lot, if it would let me. Yeah, all the way, 100 millimeters in depth. The thing you have to understand is the tool long enough to do that? Does the machine have enough scope to do that? The machine just might not have enough distance to do it. All right, so these are things to bear in mind. That's a lot to take in. If you've never done machining, I'll be interested to see what files you produce, but please produce something, because I will have a go at machining them for sure. I'll go getting that damn machine fixed. Might take 2 weeks though, because I'm on leave next week. Okay, fine. So I'm going to say partial, and I'm going to put it there. In fact, oh, actually, yeah, there we go. I'm going to go apply. Now the thing is, it's here that we can decide what our cutter is. And the thing to bear in mind is not just the length, but the diameter. So for example, if this thing here has lots of detail in it, like lots of fine detail, like this bit down here, that roughing tool will never get in there, not by a long chalk, because it's unlikely that that diameter there, that radius, is 3 millimeters. That radius there is probably too narrow to take that 6 millimeter diameter tool. So you have to use a thin tool. All right. So it's these things you have to bear in mind. So if I wanted to use like a big burly tool, like a 10 millimeter diameter ball nose cutter, there is no way it's going to get in there. All right. So you have to bear these things in mind. But that's not to say that you couldn't create other tool paths and other cutting profiles. All right, I've talked enough about that. So I'm going to select ball nose, yeah, 3 mil, apply, and then I'm going to go to finishing. The finishing is similar. It has the same features as I said, like we're going to machine the whole lot. I'm going to say depth-wise, we'll machine all the way down there. It tells me that it needs to be a tool. If I work it out, it needs to be 75 millimeters long. Quite long for a small thin tool, but we've got one, I think. But instead of using a ball nose, a 3 millimeter radius ball nose cutter, 6 millimeter diameter ball nose cutter, I'm going to use a 1.5 mil. And the reason being is because it's a finishing tool, we want to get the degree of finesse. Yes, I could use the same cutter as a roughing tool. It would still finish it in a fine finish, but I'm going to use the finer tool. So I'm going to go OK. And then I suppose that's ready. The only other thing is things called contours and scan lines. And what that is like it's the direction that it's going to go in and the mode that it uses in order to remove the material. So, for example, contours, that's like water level marks. So, for example, if you had a bowl of water or you've got a sink and you've got an object in that sink and you're filling it up with water, as the water level rises, the profile around that object, say if it was an apple, the profile of that would change. And that's called contour milling or water level milling as well. It's the same thing. Okay, so it just remove a little bit around the top, but more around the bottom. Okay. In contrast to that, you've got scanning. And scanning is rastering. And what that is backwards and forwards. Boom, 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 boom. Now, the thing is, when you're doing finishing paths, you would tend to do a combination of watermark and then scanning. But you wouldn't just scan in one direction, left to right. You'd scan back and forward, get a really fine finish. But it takes longer, a lot longer. Okay. And then finally, you've got things like cutting parameters. Well, this is the cutting parameters of styrene, polystyrene. It's got a feed rate of 900 millimeters a minute. That is really slow. I mean, I'd jack that up to like a lot, a lot more than that. And again, 500 mil a minute. But what you might notice, so with the roughing tool, you've got things like cutting amount and path interval. What that refers to is that if you've got, say, a tool out, my screen is there. I'll stop sharing for a second. If you've got like this tool, that path interval means, so if that's 6 mil, it means that it will be 3 millimeters, or in this case, 3.6 millimeters into the other path that is already cut. Now, you could have more than that. You could say, I want a path interval of 6 mil. So that's literally one pass uses the whole of the milling bit. And that works fine. You would never do that if you were doing finishing. No, you would literally use a very small percentage, like 0.1 millimeter. So it's doing lots of exceptionally fine, minute cuts. Okay. You also have something called the cutting amount. And cutting is how much downwards it cuts per pass. Okay, so in this case, it will cut 5 millimeters downwards. So if you're doing roughing, it creates quite a terraced appearance, as well. We'll have a look. All right. Of course, with finishing, I'd say you can see, but you can't see because I haven't shown down screen. Remember, sort that out. With finishing, the cutting amount is tiny, 0.3. In fact, that's quite a lot, actually. I'd have it a lot finer than that, 0.3. Okay, so as you can see, you've got a cutting amount, and it's quite small. But milling machines, unlike 3D printers, can generally work to a much higher resolution. So our milling machines will work to 0.001 millimeters. It's 1,000th of a millimeter. And were designed for dentistry, not that you would stick your head in there, because you wouldn't. I digress. Okay, so we're done there. I'm going to go finish, styrofoam. I'm happy with that. And then we're going to go to create toolpath. And that's what we're going to do. It's done the roughing. The finishing is slow. All right, so maybe, Ian, you can entertain by, I don't know, playing the banjo while I go and shift that computer terminal back to where it was and then hook up that other machine. How does that sound?
Yeah, I'll do my best.
Oh, cool.
So to add something there, Owen's now, obviously, this is kind of working in the background there. And it has to do with the roughing and the finishing. And it's working out, as Owen said, kind of the opposite of Cura. It's working out how much to cut away and writing the G code, as that kind of bar is going across there. It takes a lot longer, of course, because it's got to work out a movement, kind of working around with that cutting tool for each step. And as I said earlier, if you've got something really hard in terms like wood or a hard wood or something, instead of the 5 millimeter I was talking about, it's going to go down. It's actually just only going to go down 1 millimeter perhaps, or even 0.5 millimeter each time. So those kind of things that Owen has set up, he's had many, many years of experience in terms of running these. I'm not as confident with this as Owen is, but I'll probably refer to a spreadsheet that Owen's actually kindly put together for us. So that'll give me the idea of the speeds I should set it at and for the type of tool. But funnily enough, if this was my my tool, a general rule in some cases that you never go further than the depth, from the width, sorry, of the tool itself. I think we're done there, Owen.
Well, you're done. That's done. Okay, of course, I've just realised that I've got SRP player running, but it's for the MDX540.
And that's why the aluminium isn't there.
No, that's why it would be. I don't know why that's not there. It's weird.
As it doesn't do that. That machine doesn't cope with that material.
The 540 does.
Oh, sorry. I thought you meant the 40s. Sorry.
No. Anyway, it doesn't matter. So I'm going to show the demonstration. Now we can do preview cutting. Okay, so here we go. Let's get that out of the way. There's a lovely block of horrible styrene. There's the terracing. And there's the finishing. I did want it to machine right to the very edge, but curiously enough, it didn't. But there we go. So So there's the terracing that you'd get from the roughing. And there's the finished item. And even then, that channel there, probably still not quite enough, but that's all right. The thing to understand is, though, you might want something that has that rough, terraced look. And sure enough, that's how you can get it. And then you can scan that in using a scanner and bring it back into the digital world so you can manipulate it even further. Anything is possible. Anything is possible. So what I'm going to do, I would normally save that, but I don't want to do that. I want to go to Preferences, Cutting Machine. Oh. It is set to the 48. That's brilliant. You know what? There, how about that? It's Providence. That's Providence. So what happens is that now I go to Perform Cutting. And see, SRP Player is pretty easy to use, and it is for the safeguards. Unlike Fusion, which is difficult to use, you need to know all the stuff that you can garner from SRP Player and put it into Fusion. Now, it's a bit different for me because I've been machining using different software over the years, lots of different software. So my understanding is a bit deeper. But if, say, you were in Plymouth or in the area and you were a member of the Fab Lab, this is the kind of thing we could show you and you could get to grips with using SRP Player in order to get an understanding of how tooling and machining works, in order to then go and use Fusion 360, which is so much more detail. Okay, right, so I'm going to go output to file. And the reason why I do this is because I could launch the file directly to the cutter from the software, but I don't want to. The reason being is, if it had a power cut, I'd have to remove my laptop anyway. If I had a power cut or anything, I'd lose it. I'd lose those files that I've created. So I'm going to have them on hand if I can find them. Okay, now I'm going to save that to output, go start cutting. Now we have a choice here, and the choice is, like, when we're designing stuff, it's like the datum point. Now usually when I'm machining or creating anything for machining, I've already decided where the datum point is. It's either in the corner, and in this case it could be the bottom left corner, which is the usual datum point for machining tools or even laser cutters, or it could be the top left corner. Hang on a minute, let me get that right. So it's the left-hand corner on the bottom surface, but it's in the bottom left, not the top left of the bottom surface. That sounds really confusing. Alternatively, you could measure it from the top surface in the left-hand corner towards the bottom of the workpiece. That's really terrible. What I tend to do, I use the middle. You could use the bottom of the middle. So you are measuring, your baseline is the bottom of the plate or the machine bed, or you could use the top of the material. If you've got something that is a very specific size, you would measure it from the machine bed. But in this case, it doesn't matter. In most cases, it doesn't matter. So I measure it from the top surface. It's easier. So I go next, and then it's like, oh, ooh, what's iron raw? Let's forget what iron raw is. That's what crashed my computer earlier. Okay, so I'm going to call this SCP. This is not the lettering, is it? I could call it that. I'm not going to. How are we doing for time? We're still okay for time. I'll cancel that. We would normally save it as an XRP file, but I'm not going to. And the reason being is because it took enough time demonstrating that. I want to show you this one instead. So the reason being that I want to show you this is because this has got these meshes. These letters are standing proud. So I'm just going to rush through this as I've been through it. And we'll say that's 115, 115, 100 loss. And then we go to, that's it. We go to, we'll say it's the top. And on top, edit. Go through the old same thing, change the tooling, bish bash bosh. Oh, yeah, that's it. Yeah, okay, close. I'm happy with everything. We create a toolpath, and the reason being is because this is to demonstrate why surfaces are important and that you don't need solids in this kind of thing. And also, I need to plug in my USB somewhere. Okay, 75%, it's nearly done. The clock is ticking. I've got 17 minutes to do.
And it's perfect. Look at that.
So, right. 20.8 hours. Okay. So I'm going to preview the cutting, display model form, shape inside. And this is where you're going to see where we could use surfaces and not solids. There's the roughing. I think you're going to guess what's going to happen. And there it is. Just as I planned. All right, so that surface, those surfaces of those letters are offset. There you go. That's why you can use surfaces and not solids, which means you can be a bit more creative, and lazy is not the right word. So, okay, what I'm going to do is I've got to somehow pull my mouse out, because these beautiful laptops, I've only got 3 USB ports and I've got numerous things plugged in. Right, so I'm going to go preview, preform cutting, output to file, start cutting. That's cool. And I'm going to go, yeah, I would name it properly, but time is of the essence. So I think you'll forgive me for not doing that. Next, lovely. In fact, I didn't need to put the USB in just yet, but that's fine. And so what happens is, I'm going to stop presenting now. I'm just going to plug in my mouse again because that's slow. Okay, right. So what I'm going to do is I'm just going to find the file. Injection molding, that's tomorrow. Unplug my keyboard and send that over. So I'm going to take me and you in the form of this laptop and the camera and the tripod yonder. So this is an MDX40, a much smaller thing compared to the MDX540 over yonder. It works in 3 directions. We have the Z light up and down. If I can demonstrate, you might be able to see it. Yeah, cool. Let's have a look. Can we see into the guts of the beast?
That's good. Yep. Yeah, I'm happy with that.
Okay, so we've got the Z light here. So it's up and down. Oh, just change that to speed. All right. And we've got left and right. I think you all know what left and right is. Although I am confused about left and right. And then you've got backwards, forward. This is forward, it's fully forward, and this is back. Then it goes to bed.
And as you can see, it's the bed that changes for that axis.
Yes. Now, depending on what milling machine you use, depends on what axis moves. But essentially, the workpiece moves this way, and that way in relation to the tool. And it doesn't really matter how it does it as long as it does it. So what I'm going to do is find a bit of material. All right?
You can see a piece of wood on the metal surface. We always put a piece of wood in there. We call it a sacrifice board, really.
Now this is true. So in this case, I don't know how deep you can see that or how close you can see it. There's a recess in there. And the reason being is for things like recesses is that, yes, primarily we machine one side down. But if you've got something like those angel wings that need to be flipped over, you need to machine the other side. So it is wise to, when you're machining one side down, to also machine a very precise unit, like a rectangle or whatever it is, a shape, that you can then emulate in the sacrifice board. So you can come in at a recess, turn the object upside down, and then fit it inside that recess. Now, of course, a bit expected today, so I think that's sacrifice board out. But it doesn't matter, because what I'm going to show you is demonstrative. What am I doing for time?
About 16 minutes past, we're all right.
I'm doing all right, actually. Okay, so the question is, how do we fit materials into milling machines? And that is not necessarily as straightforward as it seems. So, polystyrene, for example, we use double-sided sticky tape. We stick it on one side and we just stick it down. Actually, that's not a bad fit, actually. Maybe. So we use double-sided sticky tape. That would stick down onto the bed. And then to find the dating point, because I've used the top, centre, we would draw an X on here, find the centre, and then we locate the tool tip to that centre, and we record that. We set that as a parameter within the software that controls this machine. Okay? But what about things like plaster of Paris? Now, plaster of Paris is powdery. Okay? You can't simply just use normal sticky back plastic. Now, we use this double-sided sticky back plastic, which is really sticky. It's like carpet tape. But before we use that, before I use that, I use hairspray and spray the base, the surface of the plaster of Paris back, as it's called, block, with hairspray, and it seals it, it creates a seal. And thereby the tape will stick to it. Sometimes it's so efficient that you can't get the tape off. Amazing. But when you've got materials such as graphite, and the reason why you use graphite is, for example, in glass blowing, yeah, making much glass blowing. Graphite has an extremely low coefficient, friction coefficients, meaning that it's extremely slippery. You can't use double-sided sticky tape on it. You cannot. So the way around it is A, you create a recess that a block of graphite can sit into. B, you then puncture it up with strips of, say, wood that is screwed into place. The main thing is, you don't want your workpiece moving side to side, because as a tool is cutting, it's going to move in a direction. Yeah? It wants to move with it. So you've got to stop it from moving. It's not going to lift up, it's unlikely to lift up, because as you are removing material, there is nothing for the tool to grab onto as it moves upwards. Okay? Now, materials that we use, like wood, and green wood is from like freshly felled trees, they haven't been seasoned. And again, green wood would be used for glass blowing. These are molds that would be kept in water. Green wood and water, they do not mix with electronics like this, but we do it anyway. That's probably why I think it's but any kind of wood that's used, they are usually glued or sometimes glued, sometimes stuck down with double-sided sticky, or actually physically screwed into place. We do not want any movement in any way, shape, or form. Okay? So, how am I doing for time? About 5 minutes. About 5 minutes and no screwdriver. It says. So I'm just going to quickly take this guy out. if I can. I mean, it's like super unlikely I'm going to get any machining done, but it's just to show you how you set up the machine. Because the question is, how does it know where the top is of the material? Where the centre is? One, of course, I've used the impact driver, but I've left that next to the ground. Yeah.
Oh, that's stuck down with sticky tape as well.
Go other side sticky tape, really stitch. And here it is. It's made by Dial or something like that.
It's essentially carpet tape, isn't it?
It is. It's the kind of thing that you might want to stick your friend to something. We'll try that once more. I'll check the back on it. So, just going to put a little bit on. I'm using a little bit more careful than that. Time's of the essence. Now, how you align it can be really important. In which case, you make recesses. Use a block bigger than it is. You machine the top off so it's like really square, right? Not the top, but just like an outside edge. Flip upside down, you stick in that recess. And that will maintain orientation. In this case, I'm just going to slam it down like that. That's my room. That's my slide, right? Jack up and Z point. Put it up. Oh no. Okay, so we've got a tool in here. I'll just move that to there. And move that back. We've got a tool in here, and it lives inside the bullet. And these are usually two nuts that are propping against each other. We test the movements with the power of the hands, and the reason why is because the hand grip and things like that acts as a good lever. Be amazed how strong your hand can be. Obviously, some people just can't do that, and that's fine as well. Like that. So, as you can see, this tool is actually quite long. Now, the file that I set up, I had it in mind for the other machine, so we could use that tool and it could machine all the way down. Of course, this little block in this little machine isn't going to do it, but that's not important. It's just to demonstrate. So normally we fit a coarse machine tool in here. You're going to get one, small one.
Basically, we've got a collet inside the machine there. You just open it up and you've got a hole within it, and then that will take, it's almost like drill bits, isn't there? You know, the different diameters of the tools that we have.
That's right, mate. That's right.
It's rather like the laser cutter. Do you remember with the laser cutter, we always had, like, in the bottom left of our kind of drawing, we'd have that little green dot, and that would be the origin point. What Owen's doing now is putting the tool in, and then the tool is going to be moved manually almost to that point where it's going to start. And once a machine has that information, then the code that's been written from what we've saved will actually run on the machine.
Okay, so I found a really nice tool. So I fitted a tiny, tiny tool there. Tiny tool. And the reason why it's demonstration so it gives me clearance. So I will direct that tool, in this case, roughly to the center. It's not important here and now. Oh, wrong way. You would offer it up by eye, like you would use your eyesight. Okay, like that. And I would say on the computer, I would set that. I'd say set X and Y origin there. And it would do it. And then suddenly those coordinates will become 0, 0. So you've got machine coordinates, all measured from here, and then you've got user coordinates. And these will become user coordinates, the 0, 0, see? All right? But to do the Z height, the height of the tool on that spot there, I hope it works and doesn't fail, whatever, we have a sensor. And this sensor is just a block of brass, could be steel. And what happens is that this tool comes into contact with that block and it creates an electrical circuit and it detects it. It's very sensitive, and as soon as it detects it, it knows to stop and withdraw. What the software knows is how thick that block is. It's about 16 millimeters. And so it detects that, it's hit that block there, it's actually 16 millimeters on the top of the surface, and then it works it out. So we put the lid down, it's an automated process. Now go to set Z origin using center, detect. There we go. It's as quick as that. Boom, done. And all we have to do now is upload the file, which I would have on my USB stick, I've got time for, and then we'll just send it to execute, and then it will come. I will produce a video of some machining happening at some point. And I think that's it for me anyway.